Hey everyone. Every product that we use, from cars to phones to medical tools, depends on one thing, and that is precision. In manufacturing, a part can look perfect to the human eye, but even the smallest difference in size or shape can decide whether it passes inspection or gets rejected. So, how do companies actually check if a part is made correctly? That's where the optical comparator comes in. For years, these machines have been used in quality control to inspect and compare parts with high accuracy. But today, the technology has evolved, and digital optical comparators are changing the way inspections are done. In this video, we're going to look at what an optical comparator is, how the digital optical comparator works, why they're becoming the new standards in manufacturing, and finally, I'll show you a quick demo so you can see it in action. So let's start with the basics. What is an optical comparator? An optical comparator, also known as a profile projector, is a measurement device used to inspect and compare dimensions of a physical part. It works by placing a part on a stage and projecting its silhouette onto a screen using lights and magnification. From there, an operator can measure features like angles, lengths, and radii by comparing the projected image to overlays or reference charts. These systems have been around for decades and are widely used because they're simple to operate, reliable, and great for quick visual inspections. However, traditional optical comparators are mostly manual. That means measurements depends on the operator, data recording is limited, and repeatability can vary. Now, let's move on to the digital optical comparator. A digital optical comparator takes the same basic concepts of inspecting a part using magnification, but replaces the projection screen with a high-resolution camera and a software. Instead of looking at a shadow on a screen, you're viewing the part directly on a monitor where the system can detect edges automatically, perform precise measurements, and store data digitally. This brings a huge advantage in terms of usability and accuracy. With digital systems, you're not just seeing the part, you're interacting with it. You can zoom, measure, analyze, and even compare it to CAD models in real time. So, how much better is digital compared to traditional? The biggest difference comes down to speed, accuracy, and consistency. Starting off with speed, with traditional systems, measurements are done manually, which can take time and depend on the operator's skill. With digital systems, measurements can be done automated, repeated instantly, and completed in seconds. Second, we have accuracy. Digital comparators use software-driven edge detection and high-resolution imaging, which reduces human error and improves measurement precision. Third, we have consistency. Because measurements can be done as programs, you can run the same inspection over and over again and get consistent results every time, regardless of the operator's skill. Finally, data and reporting. Digital systems allow you to generate reports instantly, store measurement history, and integrate with quality control processes. Overall, digital optical comparators don't just replace traditional ones, they significantly improve the entire inspection workflow. Now that we've covered what optical comparators are and why digital systems are becoming more common, let's take a look at a quick demo so you can see how this works in practice.
Here we have a part already mounted on the stage and ready to be inspected.
Before we run the automated inspection, it is important to mention that the operator can still perform manual measurements directly on the screen, similar to how a traditional optical comparator is used. But for this demo, we're going to focus on what makes the digital system so useful, how fast and simple it is to run an automated inspection.
As you can see, the stage moves along a precise coordinate system. This gives the operator better control over the part's position and adds another layer of measurement accuracy. To begin, we'll load a pre-programmed inspection that already contains the required measurements and tolerances for this part. While the inspection is running, you can see the measurements being taken automatically and displayed in real time on the screen. Another useful feature is CAD Auto Align. This allows the system to align the part with the CAD file, making sure everything is positioned correctly before the measurements are taken. Once the inspection is complete, the system gives a clear pass or fail results based on predefined tolerances. And finally, we can generate a full inspection report instantly without having to manually write down or record the results.
To wrap things up, traditional optical comparators are still used for basic inspections, but digital systems take things to a whole new level. They offer faster measurements, higher accuracy, better consistency, and fully digital reporting. If you're looking to improve efficiency and reliability in your inspection process, digital optical comparators are definitely worth considering. Thanks for watching, and if you have any questions or want to learn more, feel free to reach out.